Okay, welcome everybody. It's 4 o'clock, so let's get started with this third webinar in our series. I hope you're all doing well wherever you're from. I guess most of us are still sitting at home, working remotely. So that's why we started these seminars, these webinars, also had to do something additional in these strange times. This is the third one in a series. I see a number of you have seen previous webinars. Perhaps some of you I see are new. If you want to have a look at the previous webinars, and I'll use a bit of the things discussed there, but it's not essential to follow this webinar. But if you want to have a look at them, we posted them on YouTube, so you can have a look at them over there. And if you can't find them, just send us a mail, and we'll send you the link. So this webinar is on chat calculations. So the first week we talked about forecasting and fluctuations, how they affect forecasts. Then last week we kind of translated that to the situation of inbound calls, and that is related to the Erlang formulas. And this week we want to look at chat. And chat, of course, is relatively new. So, the Erlang C has been around for a long time, but how to schedule for chat and what are the challenges do you find? That is the subject for today. So to be more specific, what are the contents? Last week, as I said, we did Erlang C and Erlang X for safety staffing of inbound call centers. And now the subject is chat. And before we go talk about chat, about the details of chat, I want to talk about two properties of Erlang C and Erlang X that are essential in understanding things I'm discussing today. And the first thing is scale. I guess you're all in a way familiar with that, but I want to discuss that. And another thing is what exactly handling times are and how we should define them if we want to look at capacity calculations. Yes, because in chat, because agents are doing different chats in parallel, you have to come up with a good definition of handling times to be able to do capacity calculations. So if you have discussed this, and these are, I think, are of independent interest, but they help us in understanding chat. And I realized what we're going to do, I'm going to show you how to do capacity calculations in chat. And I realized that some of you might already use our tooling that can help you doing that, our Erlang chat. But I hope also for you that it will give you some more background on how these calculations are done. And then I will dive a bit deeper into some practical challenges, partially based on a discussion I had a few days ago with Stefan van der Kerkhoff, who is also in the listening right now. Welcome to you also. Because chat is relatively new. Many companies are using it, but often still in experimental phase. So I guess we're all still learning how to handle chat. And I would like to discuss some of these things as well. Okay, let's go into the subject. Let's dive into scale first. Now, what you see here is where we started 2 weeks ago. What you see here to the left are arrivals to a call center with average 10. And here you see the number of arrivals minute to minute. So now we have forecasted, we have perhaps forecasted for a 50-minute interval. We have forecasted 150 calls. That means that you expect 10 calls per minute. But what you see, of course, is that not every minute there are 10 calls. So here you see fluctuations. Here you see perhaps another line, another queue with the same forecast, and you see a realization again of 50 minutes. You see fluctuations. Yes. Now, if you simply add these two, then you get something which is on average 20, the line you see here. But here, of course, this is scaled a bit differently. The average, the mean is in the middle. And as you can see, this figure shows less fluctuations than this figure. Yeah? So what we see here is both have a mean of 10, and the sum, of course, has a mean of 20 per minute. Every minute, what you expect is 10, and overall the mean is close to 10. The two left figures close to 20 to the right. But you see there are less fluctuations. And 2 weeks ago, and I hope you remember that, otherwise, please have a look at the YouTube video. But we formulated, there I gave a formula in which you can calculate the error. The error that comes, that you see here. And this error, we defined the MAPE as the way to measure this error from the mean, from 10. And here, this error is around 25%. And so MAPE stands for mean absolute percentage error. Yeah? So that is as a percentage with respect. So it's relative to the 10, but you expect fluctuations of 25%, so around 2.5. And of course, one time you're exactly 10, next time you're at 5, but on average, it's 2.5 because the mean is 10. Here, of course, it's the same, but here, as you can see, this MAPE does not scale with the average. Yeah? So I summed these two, and what you see, it's 18%. Yeah, so it means that if you go to a higher scale, yes, if you have more arrivals, then you see that the fluctuations, relatively speaking, are less important. Yes, you can formulate this mathematically. There are formulas for that. Let's not dive into this. This is really applied to call center arrivals, what you see. Yes? And we saw that the more fluctuations you have, the harder it is to forecast, but also the more safety staffing you need. So increasing scale makes forecasting easier and makes that you need less safety staffing. And that's, of course, the reason, one of the reasons why we like to have multi-skilled agents, because then you can kind of merge different lines. Yes. So as I said, you also see that in the safety staffing. So what I did here, I did some calculations in the Erlang X tool that I showed you last week. I'm not going today to the tool itself, but here is some output. And if you have access to the tooling, you can reproduce it, and you can also reproduce these numbers on the even on the online calculators that we have. But here you see 2 call centers, or actually 3 call centers. The first and the second are exactly the same. They have a forecast of 4 per minute. And if you do here the calculation, and I say, okay, I want 80% service level, what is the number of agents that I need? Well, then you need 14 agents. Now the load is, as you might remember, 4 times 3, so that's 12. So the safety staffing is 2.6. So that is 21 or almost 22% safety staffing that you need in this situation. Yeah? And again, perhaps you remember in this Erlang X in the Excel add-in, it's a broken number, which is helpful if you want to add shrinkage, for example, after it. And it gives you an impression. You can always do rounding afterwards. If you double, so these are 2 separate call centers, both with a forecast of 4. Now, if you double this and you take 1 call center with a forecast of 8, that's like merging the 2 call centers. And then you do not need 14.6 plus 14.6 is 29.2 agents, but you need a little less than 27 agents, as you can see here. So at the percentage-wise, the safety staffing is less. Instead of 22%, you need 12%. So this economies of scale that you saw in the fluctuations, that you saw in the MAPE, also translates to the safety staffing, also translates to the Erlang formulas. Yes. So what we see we see a lower need of safety staffing, all relatively speaking, in the sense that here the call center is twice as big. Of course, you need a bit more safety staffing than one of these call centers, but relatively speaking, it goes from 22 to 12, or different, saying it in a different way, if you merge two call centers, then you need less staffing in total. Yeah, again, one reason to go to multi-skilled agents. Of course, there are also lots of other reasons, but also challenges. But perhaps multi-skill scheduling and staffing, that might be a subject for another webinar. Okay, so much for SCIP. That is one of the things I wanted to touch upon before going to chat. The other thing I wanted to discuss are the handling times of inbound calls. And in last week's webinar, I assumed that the handling times are just given and that the system gives them to you. Yes, but it's easy to make, if you have to do the calculation yourself, it's easy to make errors in it. So let's look at a bit more detail what happens exactly to a customer. So a customer calls, perhaps comes into an IVR where he or she selects one of the queues in some way. Then the customer enters the queue. Perhaps there's not an agent right away available. So the customer has to queue for a bit of time, hopefully not that long. And that depends a bit on the system that you're using, but then an agent becomes free. And then the call is transferred to the agent. Now, sometimes the agent gets the call right away, but sometimes the agent has to do something to accept the call. Yeah, and let's call that ring time. So that means that for a couple of seconds, this call, the customer is still waiting, but already an agent is assigned to that call. In exceptional cases, the agent, it doesn't see it, is perhaps not behind his or her desk, and then the call is transferred. But in most of the cases, after a couple of seconds, the agent will pick up the call, and then the actual conversation will start, which I call here talk time. And then the call is ended, and that depends a bit also on the situation, but in many situations there's after call work, and right after the call, the agent has some time to wrap up entering information in some IT system, etc. And then the call is ended, and then in principle the agent is available to take the next call. So actually, the customer waited, and we do not see the time in the IVR as waiting time, but the queue time and the ring time, that is actually the time that the customer waited. Yes, but more importantly, perhaps, this is the time that the agent was assigned to the call. Now, you might say, well, this ring time is irrelevant. It's all about talk time and probably also about after call work. But what is important for the Erlang calculations is that during the ring time, the agent was already assigned to the call. Yeah? So if you do your safety staffing calculations, then you should take this ring time, if that applies to you, into account. Yeah, but the important message here is also you should look at the time that the agent is assigned to a call and cannot take another call. That is the time that is important for the safety staffing. So that is also the handling time that you should use to compute your average handling time in the Erlang safety calculations. Okay, so this is like preliminary. Now we're going to move to chat staffing. And the question is, how many agents should we schedule for chat? Yeah, so you have, so like inbound, it's customers who initiate it, perhaps in a different way. Perhaps they click on a button at a certain website or at some page in your website. So it's initiated in a bit different way, but in principle, it follows the same pattern in the sense that it initiated by the customer, and that you want to answer it in a similar service level as Erlang models, where you want to have an agent available to handle the chat, let's say in 20 seconds. Yeah, but the biggest difference with respect to inbound is the fact that your agents can do multiple chats in parallel. Yes, now I've seen different numbers, but most often I see, well, sometimes three, most often two, sometimes two, most often three, sometimes four. But this agent can do multiple chats in parallel. Yeah? And I just mentioned handling times. What I want to do next is really dive into the handling times. Yes, because as you can see here, and this is like the screen of the agent, and having three chats in parallel, but perhaps I should have taken. Well, this is the agent, of course, so three times the same picture. Of course, the agent pays attention in an alternating fashion to these three chats. Yes, and so we have to think of what is the average handling time and how should we use that to come up with the service level prediction. Yes, because of this and because of this parallelism, this is really different from the Okay, so let's have a close look. What happens inside such a chat? Yes, so now let's first look at one chat. Yes, suppose the agent does one chat at a time, perhaps because there are few chats, that's just the chat he or she is doing. So it depends a bit how the chat is initiated, but perhaps there's some automatic message, and then the customer is typing, customer saying, oh, I have a problem with something, or a question about something, or can you give me some information about something? And then, of course, the customer types enter, and then it's up to the agent to answer. Yes, and then the customer might type again, the agent answers, and then it's turned to the customer, agent, etc., so that alternates until the chat ends. Yes, and of course, the idea is that while the customer is busy, the agent could work on a different chat. Yes, so that is the whole idea of doing multiple chats at the same time. Yeah. So how does this work? Well, let's look at the situation of two chats in parallel. Yeah. So one chat is exactly the same as the previous one, with one exception. At some point in time, the agent is not available because the agent is busy on another parallel chat, yeah, on the second chat that is going on. So let's have a look how this alternates. Yeah, so in the beginning, let's assume perhaps they started at different times, but it's about the general idea. Here, both customers are busy. Then the agents start answering the first who was ready. Then the second customer is starting to wait for an answer, but as you can see here, the agent is busy on the other chat. Of course, the agent cannot pay attention to both at the same time. Then the agent is finished with the first chat. Then he or she moves attention to the second chat. Then here, again, both customers are typing, so the agent is idle. And then here, here the agent is busy with the first chat. Then the second chat is waiting. Then he is busy with the second chat. First chat is waiting, etc. Yeah, so this way it alternates. As you can see, of course, the agent is now. So sometimes a chat has to wait, so a customer has to wait. Yeah, so that means perhaps a bit lower service level in the sense that, well, that the customer has to wait longer for an answer. On the other hand, and that makes the handling times a bit longer. On the other hand, you can see that the agent is busy most of the time because he or she is busy, can alternate and can use the times that the customers are entering, are typing, can use that time to answer other questions. Yes, so more efficiency for the agent, a bit longer handling times, because of agent being at that moment busy with another chat. In an ideal situation, that wouldn't occur. So I'm just to clarify this a bit more. The ideal situation would be this. Let's say the agent does 3 chats in parallel, and exactly when the agent finishes working on chat 1, chat number 2 is waiting for an answer. and exactly when the agent is ready on chat number 2, chat number 3 is ready to be answered. And then miraculously, when he or she is finished with chat number 3, it's chat number 1 wanting his or her attention, etc. So here you can see ideal, I don't know if that's ideal, 100% occupancy. That's perhaps too much for the agent, but from a efficiency point of view, this is like the ideal situation. And also from a customer point of view, because the customer gets the answer as fast as possible. Yeah. So this, of course, is not possible. Why? Because we have the fluctuation. So what we saw on the previous slide is more the realistic situation, but I think it's good to see this to set up our thinking about this. And as you can see, sometimes agent is sometimes the agent is busy on other chat, so chat has to wait. But overall, the occupancy of the agent is more effective because he or she spends more time really working on the customer. Okay, so what is the reality? So what actually happens, and perhaps let's go back here. As you can see, and of course this is just an example, as you can see, these chats are longer than this single chat because of these busy periods. They get longer, yes? But because you effectively use the time that here the agent is waiting for the customer, these chats are not twice as long. Everything is on average, but they are not twice as long as these chats because you use, to a large extent, the empty, here the idle periods when the customer is typing. Yeah. So how does this work out in reality? Yeah. So it means that if an agent is doing one chat, yes, he or she takes less time. When he or she is doing one chat, he or she is taking less time on a chat than when he or she is doing two chats, but it's not twice as long. Yes, it's less. It's a bit longer, but not twice as long. If it would have been twice as long, then there's no sense in using this parallelism. So let's look at that. This is some data that we analyzed that we got from a colleague in Brazil, Daniel Lima. He is also interested in workforce management. So we have some, through him, we have some Brazilian customers, and I gave some trainings in Brazil. And he also helped us already quite some time ago to better understand chat. And based on, we analyzed some data that he gave us. Yes, and we looked when agents were doing one chat at a time, when agents were doing two chats at a time, and when agents are doing 3 chats at a time. So as we can expect from what I just explained to you, when agents are doing one chat at a time, the average handling time is shortest. Of course, they are not most efficient because they only deal with one chat, but the handling times are the shortest. Yes, and actually, they were in this particular situation quite long, almost 17 minutes. Now, if the agent was doing 2 chats at a time, then of course the handling time got longer, but not that much longer, actually 36 seconds. And then if it is, if you add a 3rd chat, then it got also a bit longer, but again, not that much. Yes? So I think what you see from this data, that it really pays off in terms of efficiency to have multiple chats at a time, to have here, to allow for 3 chats at the same time. So I think this data really shows this. Yes. By the way, this for us also, we have, as you might know, strong connections to the university here in Amsterdam. So we are interested in analyzing data, both to help you get this, to obtain similar insights, because this is not something that your system will give you, and this is not a trivial to get this out of your data, these numbers, but I think it would be interesting from well, as to get more insight into how chat functions to get these numbers for multiple call centers. So if you're interested in it, to please contact us, and then we can try to get these numbers out of your data. So what to do with it? Yeah, now we want to use these insights, and now we kind of have all the ingredients. Remember Erlang C or Erlang X, you need the forecast, you need the average handling time, perhaps you need patience, you need the acceptable waiting time, the 20 seconds in the 80-20, and then you can start doing your calculation, your safety calculation. So we wanted to do the same thing for chat, yes, but of course, this is not the regular Erlang situations because of agents doing multiple chats at the same time. Then you can say, okay, if you have 10 agents doing 3 chats at the same time, then it's like having 30 agents. Yeah, that is not a very bad approximation, yes, but then you miss this parallelism that I had, these difference in handling times that I just showed you. Yeah. So what we did actually, and one of our developers, Alex Raubos, did the actual programming, but based on our discussions, we came up with a separate chat calculator that is in a way based on similar logic as Erlang X, but that internally works a bit different because we take this parallelism into account. I cannot, I could go into more details, but then things really become very mathematical. And of course, that's, then I need much more time. And also, perhaps you need more background into the math, but your people from practice, and what is of course useful for you is not necessarily to know all the details, but also to have tooling working for you. So here is I made a demo sheet in the Office 365 version that I showed you last week of the Erlang X. So this is the Erlang chat. Again, some of you are using perhaps our regular Excel plugin, and then you can get, of course, exactly the same results. So let me just go through this to explain and to show also a bit the differences with Erlang X. As you can see, we have, again, of course, a forecast here. So I took here 1 per minute. I used the numbers that Daniel gave. So here you have to enter the average handling time, and depending on how many parallel chats you have. So here you see the numbers he gave. Here you have the average patience per caller. We discussed this shortly, how to determine last week, how to determine this. There is also some data analysis involved, but setting it to 5 or 10 is perhaps a safe choice. Basically, you could say in Erlang C, if you look at patience, that's like all customers have an infinite patience. They wait until as long as they need to get to the service. So here you have the same thing, but of course, then the service process is different because of these parallel chats. Acceptable waiting time, 20 seconds. So here, what I took was 6 agents. And if you do this, then you get an average speed of answer of 70 seconds and a 60% service level. And here you can see the backward calculation. Here, because well, you need to have a certain number of agents dealing with these, dealing with the chat. There's no, there is rounding. So actually, so you need 7 agents to get to 80% service level. We could, but actually, if you would fill in 7, then the actual service level is, of course, a bit high. It's perhaps interesting to see how you have to enter it, because what you enter looks very much like the Erlang X. The only thing is, instead of 1 number for the average handling time, you have to enter multiple numbers. you have to enter these 3 numbers. In here, you enter them by entering, well, as you normally enter an array of data. So you enter these 3 numbers at the same time, and the chat calculator knows that you can do 3 in parallel because it sees here these array of 3 numbers coming in. Yeah, so that's how it realizes, okay, apparently you can do 3 chats in parallel. Well, if you look at it closer, this, by the way, is the number of lines. So you could restrict the total number of customers that are, total number of chats that are being helped or in line, but I didn't include this, so I just took a big number. Yeah? So this is without, of course, I could have gone like I did last week to the online demo and do these numbers online. I decided not to do that. I did that last week, and I just took this screenshot of it, but I hope that it's clear how this functions. Yeah, so this basically tells you how many agents to schedule for chat, assuming that you have a forecast and assuming that you have an idea of these average handling times. Yes, and be a bit careful with that, because if you take the overall average handling time, and that depends, of course, how busy it is, but then it might be, then these numbers, you might take them the same if you do not know what the difference is between parallel chats, but then this number, when the highest level of parallelism is achieved, is the most important number, because this is when the system is most crowded. Yeah, so you should might be a bit well, careful if you all fill in the same number. On the other hand, if you only have 1 number to fill in, you should still fill in 3 numbers, because again, then the calculator knows that you're doing 3 chats in parallel. Yeah, but in any situation when you're using tooling like this, you should, of course, always try to make your own load calculations, because to see if your answer makes sense. Okay. So this is the Erlang chat. Next subject is the WFM challenges for chat. So as a preliminary step, I talked about scale, I talked about handling times. Now I showed you and I gave you an idea of how the calculator works. Next thing is, okay, if you want to use chat in practice, what should we think about? Yes, and again, with Stefan, I had a conversation a few days ago, and to get some more practical feedback on this issue. So I want to talk first. The question is chat more efficient than inbound? Yes. So you might think, and then I'm going to talk about chat and scale, and then I'm going to talk a bit about routing, and I'll explain in a minute what I mean to that. So you might have the idea when you think about chat, okay, when doing inbound, an agent is listening half of the time. Of course, this is important information, but the agent is not really active, and you might compare that to chat, where you say, okay, when the customer is typing, the agent is busy with a different chat because of the parallelism. So an agent is always occupied when you're dealing with chat, and that means that that should be more efficient. Yeah. Well, yes, that you might think that, but I am not yet completely convinced of that. Yes, because of course, if you're doing 3 chats at the same time, yes, then of course these chats may be longer than 1 inbound average handling time, because you're doing 3 at the same time. But perhaps the whole process is so much longer that it's perhaps more than 3 times longer than your inbound average handling time. Yeah, and then it still gets slower. Yeah. So if you look at this Brazilian call center, we saw that if you're doing 3 at the same time, when you're most efficient, when you're really full, then it was like 17.5 minutes. So that kind of means that you have like a little less than 6 minutes, 17.5 divided by 3. that would be the comparable average handling time in an inbound situation. Yeah? So unfortunately, this is a comparison that's a bit hard to make, and I don't know the inbound. Perhaps I should ask Daniel. I don't know the inbound average handling time of this particular call center. But I think it's worth making this comparison. And if you ever think of introducing chat or busy doing it, I think it's worthwhile looking at that. And I do think that that will depend on the situation. So that's one of the reasons why I'm interested in analyzing more data and better understanding the efficiencies, because it might depend on the situation whether chat is more efficient than not. Of course, there might be other good reasons to introduce chat. You might find it very customer friendly, give more options to the customer. There might be even some legal reasons because it's written down. It means also that it's easier to analyze, yes, because text is, of course, you can analyze it right away. And if you have voice, then you first have to translate that to text, and there might be some errors in the translation. So might be good reasons to introduce chat, but from a WFM point of view, I'm not convinced that it is a smart thing to do in different situations. And as I just said, I would love to have more data on this. And okay, I see a question coming in on the chat from Nuria. Hi, Nuria. We will look at it. I will look at it in a second. Yes, and. I think that Wout, who is helping me, if there's any chat coming in, he will also have a look at it. Two more things that I want to discuss in a little bit more detail. So I started with scale in the very beginning for a good reason, because I think it's important, especially when you're introducing chat. And then routing is related to that. So oops. Oh, this. Let's go right away here. This picture should have been like this. Okay, chat and scale. Yeah. So what I see in most of the call centers we talk to, and there are some exceptions where chat is the only channel, but in most call centers that we work with, we see that chat is often introduced as a small scale next to inbound, that people are still experimenting with it, that want to try out this new channel. Yeah. Now, from what I said about the economies of scale, you will understand that the agents working for chat, that their occupancy will be really low because you have this small volume, because you're still experimenting with it. Perhaps you're not offering it all the time. Customers are not used to it. So you're you're kind of splitting up your inbound into two streams. So that already decreases the economies of scale. And certainly in the beginning, chat will be really small, requiring a lot of safety staffing. Yeah. So what I see, next to the potential problem of very long handling times, is that because it's such a small scale, you lose a lot of your precious capacity on chat. Yes, and so how could you avoid this? Well, in general, and that is again a different subject, but I think also a very interesting subject in all the multi-skill, multi-channel call centers we see nowadays. And also we work quite a lot with international call centers where you have small skills because people from different countries speaking different languages and all getting to the same call center. So what we see is that you have to deal with these small skills. So you have to somehow make sure that if people are not busy with their primary skill, that there is other work that they can do to reach a reasonable occupancy. And I think certainly when you're introducing chat, as we're talking about it here, even more so if you have different specialists per skill, that that blending is a way to increase their occupancy. So here in this particular example, you see one agent handling 3 chats. You see one agent not fully occupied with only 1 chat. And then you see a third agent who is ready to do chat, but because there are no chats available, he or she is doing an email. Yes. Now, if you want to organize things in such a way, and if you're interested in doing computation, we also have tools and calculators that can help you schedule blending in a smart way. But well, let's not go in these details right now. But what you should do, you should then do the routing in the right way. Of course, if you would split all the chats equally over the agents, yeah, then there wouldn't be an agent available for email. Yeah, and so if you want to do blending, then you should really try to fill up the agents as much as possible with chats, and then you need some smart rule to decide when an agent can do an email. And of course, an email is somewhat easier to schedule than an inbound call. Yes, because an email you can interrupt it. Yes, if there is, if incidentally there are many chats arriving. If you're blending with, for example, inbound calls, that's also a possibility, but then you should really make sure that your routing is smart enough to account for fluctuation. But this is possible, and that is also a way to avoid this low occupancy on these specialized agents. Yeah, so it's important to do this in the right way. So this also means, yes, if you do that in this way, that it's not longest idle agents that you're using here. Yes, the routing policies should be smarter than that. That's also that we see as there are more possibilities also for different channels. We see that routing gets more complicated, and if you really want to get the most out of your call center, there are lots of things possible. But to make use of these possibilities, your routing should really do it. And it's a pity if you route in the wrong way and you get a low occupancy because of that. Okay, so let's. I'm ready to wrap up. So what we saw, I discussed a few properties of basically a general property about scale, an important thing, and I talked about chat calculations. I talked about certain issues. I finished with that when introducing chat, when introducing this new channel. Okay, so I hope this gave you some insight into chat and how we think that you can handle chat and include it in your regular WFM processes. I've shown you some screenshots of our Erlang add-in that includes this chat functionality. Some of you are using this already, and then you're still using the local version. And what I've shown you is a new version that we're developing that works for Office 365. If you're interested, well, you know where to find us. Next week, well, it's actually not next week. So next week is the Easter weekend. Well, most of us will probably stay at home because of the current situation, but many of us will also take the opportunity to be there together with your family, perhaps. So as next Friday is Good Friday, so we will skip 1 week. So the next webinar will be on April 17 in 2 weeks. If you have good ideas about a subject, please mail us. So let us know. So you can send me an email if you want that. Okay. Thank you for your attention. We have now time for questions, and there was Nuria gave me sent a question. Let me read it. I'm working for the International Computer Center, United Nations Agency Service. Yeah. Okay, if you have multiple, Nuria, that might be an interesting for next week. So you say I'm working for a computer center serving 60 different agencies and service desk services. Most calls come in through email. And how do you calculate the number of agents? So that is, how do you staff for email? Yeah, and you have different service levels, probably depending on the type of issue that you have. So you have different email, of course, you don't have service levels like 20 seconds, but in terms of multiple hours or days, and you suggest that you have different service levels per type of, yeah, that could be a topic for next time. Very interesting. I might, if that's okay, then I might contact you to get some more details on your particular problem and what you encounter. How could you do capacity? Let me see. How could you do capacity planning for chat in a context that were different today? That's an interesting one, where different agents are configured to take different numbers of simultaneous chats. I would have to think about that. In our calculator, indeed, we assume that all the agents have the same amount of parallelism. Of course, it is potentially always possible to dive into the mathematics and come up with the possibility that some agents take more chats than others. But that makes it a bit more complicated. You can always, you can always simulate it, and I think so in our multi-skill, and certainly when you start blending and start to do multi-skill routing, skill-based routing, then it's important to realize that your Erlang formula cannot be used, and the tooling that I just presented is also for a single skill. So if you have multiple skills, then in principle Erlang cannot be used anymore. So then simulation is a tool which is often used, and yeah, and that might be helpful. So please contact us, and then if you're interested, and then we can see what we could do. We blend email and chat. Some activities. We blend emails. Okay. We blend emails and chat for most of our chat queues. Some are really super blending with both chat, email, and voice. Yeah. But that makes the capacity planning challenging, as Michael, as you said. But this is indeed okay. Very interesting. Here, Ivo says. As far as chat goes, to the agent that has the longest available slot. Yes, so that means that you distribute it evenly. And I agree, that is similar as for inbound calls. That is what often happens. And then it's distributed evenly. That is fine. As long as you don't want to do the blending. But if you want to do blending, you don't want to do that, because then if you have 10 agents and you have 10 chats, then they're all 10 occupied, and then you cannot send an email to one of them. While on the other hand, if you would try to aggregate it, you cannot fully do that because sometimes a chat finishes, and then you cannot take a chat from another agent to fill up this agent again, to say it in this way. But of course, if you aggregate it, then in the ideal situation, if you have 10 agents, 10 chats, 3 in parallel, then you only need 4 agents to deal that, and that potentially you can use 6 agents to do emails. Yeah, so what you say, longest available slot distributes it evenly, and then you cannot do the blending in a smart way. Okay, interesting questions. Are there and remarks? Thank you very much for that. Are there any other remarks or questions? If not, then I would like to thank you again for your attention. If any of you want to know more or is interesting in has data that you want to share, and as I said, I'm also interested in other data to learn about handling times in different call centers as a function of the parallelism. But you know where to reach us. We will send an announcement in 2 weeks' time. If you have ideas, please share with us. We will again share the YouTube video with today's webinar. Despite of the situation, I hope that you all will have a great weekend, and I hope to see you healthy back again in 2 weeks' time. Bye-bye, and thanks again for your attention.